Hi, my name's Tom Traeger and I'm a high school earth sciences teacher. We're currently learning about climate change in my class. Climate change is part of a complex process. We learn that carbon is naturally released into the atmosphere and then absorbed over again and again. And we also learn how human activity can upset this balance. I'm finding that the more I teach my students about climate change, the more questions they have.
Why is carbon dioxide so important?
Carbon dioxide is a major greenhouse gas and is argued to be a leading contributor to global climate change.
And it's primarily coming from human activities. Some of those human activities that are emitting carbon dioxide into our atmosphere include the burning of fossil fuels. Because of this, we've been building up the concentrations of this gas in our atmosphere very, very rapidly over the last 50 or so years.
How much carbon dioxide are we actually putting into the atmosphere?
Every year, human activity is responsible for approximately 8 billion metric tons of carbon being released into the atmosphere.
Just what is a metric ton of carbon?
1 ton of carbon would be the equivalent of, say, a small convertible sports car, okay? Now, 8 billion of those are put into the atmosphere every year. That's more than 1 sports car or 1 ton of carbon being put into the atmosphere for every man, woman, and child living on the earth today.
So where is all that carbon going?
Approximately half of the carbon dioxide that's emitted by human activities remains in the atmosphere. The other half of that carbon dioxide is disappearing. It's being absorbed by the oceans and by the terrestrial biosphere. But we don't know where it's being absorbed.
How are you going to figure out where all that carbon dioxide is going?
The Orbiting Carbon Observatory is really NASA's first truly dedicated mission for measuring CO2 in the atmosphere.
This satellite then will allow us to find out where the carbon dioxide is coming from, where it's being produced and emitted into the atmosphere, and where it's being reabsorbed into land plants and into the oceans.
The satellite brings back hundreds of thousands of measurements per day. And so by making so many more measurements over much more of the surface of the Earth, we can increase our understanding just by overwhelming the problem with more data.
Well, why is it important that we know exactly where all the carbon dioxide is going?
One of the fundamental goals for the Orbiting Carbon Observatory is to obtain the necessary information and data so that policymakers, not just here in the United States but throughout the world, can make better informed decisions.
OCO measurements could give us an indication of how much longer we can burn fossil fuels at the rate that we're burning them now. How much more CO2 we can add to our atmosphere before it does produce climate changes that are unacceptable. But we need the measurements that spacecraft like OCO will make in order to understand the processes controlling the rate of buildup of carbon dioxide in our atmosphere so that we can understand how it will change in the future.